Dear students, now I am going to solve the next question of the book A.C.VERMA, that is Concept of Physics. And this is question number 4. And the question is given in this book that a block of mass 0.2 kg is suspended from the ceiling by a light string. Okay. And a second block of mass 0.3 kg is suspended from the first block through another string. Find the tension in the strings, in the two strings. And we can take G as usual as 10 meters per second square. Now, let me first observe the system and make a diagram of it. This is the first step, I have told earlier that whenever you want to solve a problem, the first step should be step 1 that I have told earlier, that observe the system. So, what is the system here? Let me observe it and give a picture of it, okay, in the form of picture or in the form of a rough diagram. So, here the first statement is a block of mass 0.2 kg is suspended from the ceiling, okay, by a light string. So, this is the first thing. So, this is the ceiling and a 0.2 kg block is suspended from this ceiling by a light string. So, you can take this thing as massless, as it is mentioned that it is light string. Now, the second block of mass 0.3 kg is suspended from the first block, that is from 0.2 kg block, by another light string. So, there are two strings, so two different tensional force will arise that I have shown here, and I have taken this tensional force as T1 and this tensional force as T2, and we have to find out this T1 and T2. Now, what will be the next step? Next step should be the free body diagram of each and individual block present in the system. So, here two blocks present in the system. So, I have to make two free body diagrams separately by choosing a conventional coordinate system, that is simply a two-dimensional plane, a two-dimensional coordinate system, Cartesian coordinate system. So, this is the plus x-axis and this is the plus y-axis, and the opposite directions are as usual, respectively minus x and minus y. So, let me first draw the free body diagram of 0.3 kg. So, for this 0.3 kg, what are the forces acting on that object? Now, next step should be, you have to look what are the forces acting on the object for which we are going to draw the free body diagram. So, here I am going to draw the free body diagram of 0.3 kg. So, I have to look the forces that are acting on the 0.3 kg, not the forces that are given by 0.3 kg to the others. Okay, we have to visualize the forces that are acting on the 0.3 kg, and two forces are acting on the 0.3 kg. One is due to its mass mg, that will be downward direction. In this downward direction it will be mg, and another will be in upward direction, that is tensional force. And I have shown, as I have said earlier when I have discussed the theory part in tensional force, that it will always be away from the object. So, the tensional force in this string due to the mass 0.3 kg or on the mass 0.3 kg will be away from this object, that is T1, that is upward direction, that is along the plus y direction, and 0.3g, that is the mg here, m at 0.3, so it will be 0.3g, that will be in downward direction. Now, what you have to do? You have to use the Newton's second law, and that is summation in the component form actually. Okay, and in the component form, the Newton's second law is defined as summation fx is equal to max and summation fy is equal to may. Okay, so here I have to use summation fy because the forces are in the y direction, or along the y direction. So, I have used summation fy is equal to 0 because the system is in equilibrium, no acceleration is present there. So, the right hand side of the equation will obviously vanishes. So, it will be summation fy is equal to 0. And summation fy, when we take summation, that means we have to substitute or we have to take the summation with sign. Okay. So, here as the T1 is along the positive direction, so I have taken T1 as positive, and 0.3g is in downward direction, so I have taken 0.3g as a negative. So, it will be T1 minus 0.3g is equal to 0, that means T1 is equal to 0.3g, and as we have to take g is equal to 10 meters per second square, so multiply 0.3 with 10, you will get obviously T1 is equal to 3 Newton, and that is nothing but the tension in this string. that is the string between 0.2 kg and the 0.3 kg. Now to find out the tension in this string, that is the string between the ceiling and the first object 0.2 kg, we have to draw the free body diagram of this 0.2 kg block. And again here you can see the three forces are acting now on 0.2 kg. Why? Because one is due to its mass mg, 1 mg, you can say m dash g is in downward direction, and another force is, there is a tensional force that will now be away from this object, this is in downward direction. So now the T1 on the 0.2 kg is in the downward direction, but the T1 on the 0.3 kg is upward direction, because always the tensional force will be away from the object, and here the direction of away from the object is upward direction, and here the direction is downward direction. Away from the object is downward direction. But for this string, the tensional force will be now in upward direction, because for this string, the away direction, the away from the object direction is upward direction. So here in the free body diagram I have shown here that T2 is in upward direction and T1 is in downward direction, and in addition to that there is another force m dash g, and here m dash is nothing but 0.2 into multiplied by g. Okay, so now again you have to apply summation Fy is equal to 0, because again the forces are along the y direction, and if the forces are not along y direction or along x direction, then we have to resolve it into components along y and x direction. We will see later on the more complicated problems. Okay, but now here we are very fortunate that the forces are always in the along the y direction. So let me use summation Fy is equal to 0 here again. So you will get T2 is in upward direction and T1 and 0.2 g in downward direction. So T2 minus T1 minus 0.2 g is equal to 0, because this T1 and 0.2 g is in downward direction, so we have to take the negative sign for this force. And now if you solve, you will get T2 is equal to T1 plus 0.2 g, and T1 is nothing but 3 Newton. We have get from here, we got from here. So 3 plus 0.2 into 10, that will be 2. That 3 plus 2 will be 5 Newton. So the tension in this string will be 3 Newton, and in this string will be 5 Newton. So this is the complete solution of this problem, question number 4.